Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Dr. Ezrin Hani, your coordinator of Human Factor in Engineering class. Today's topic is Human-Machine System for Facilities and Workstation Design.
Before we proceed, let's see the learning outcome of this topic. At the end of this topic, students should be able to 1. Understand the human-machine system and its interaction. 2. Understand the approaches which is systemic and cognitive to investigate the human-machine systems problem.
Human-machine system is a system in which the functions of a human operator and a machine are integrated. This term can also be used to emphasize the view of such a system as a single entity that interacts with external environment. In order to human to be connected with the system, there are interfaces that become their bridge. For example, we take a look at the system of human interface and computer, which is computer as a machine. Computer has displays and controls. All those displays and controls become interface for human to be able to communicate with the computer. Meanwhile, for human elements, there are sensory stimuli and motor responses, which will affect how human react with the system interface and decision making is made. In the workplace, the human-machine systems consist of three main systems. First, human component, which includes all human characteristics like anatomical, physiological, and psychological elements. Number 2, machine component, like chairs, tools, and equipment with which the human being interacts. And the last one is environment. It is the place that the circumstances in which the work is carried out, and it includes physical and social aspects. In the previous slide, I did mention about the three main systems. One of the system is environment that consists of physical and social aspects. Here are the examples of those physical and social aspects. The physical aspects include noise, vibration, light, climate, and chemical substance. Meanwhile, for the social aspects includes the family and the surrounding people as colleagues. When we talk about human-machine systems, we need to understand the human-machine interaction. Human-machine interaction is a continuously growing domain of interest of researchers and practitioners. It's a consequence of even more and more complex technologies and systems controlled and managed by humans. Human-machine system may help us to determine workplace problem. The problem is detected from the perspective of safety and reliability of human component in human-machine combination, efficacy and quality of the production, and also for the economy and sustainability. Now, I bring you back to the scenario of human interface computer. What will happen if we have poorly design of user interface? Poorly design of Instagram or Facebook, for example, it can cause rejection and rare using. And what will happen if the interface of more complex system in the hazardous plant or workplace? The poorly design of user interface will cause catastrophic human errors. Confusion, misleading presentation of information can be happen. Misinterpretation and will cause of dangerous actions. In 1997, Swan Storm emphasized that human-machine interaction should be modeled from the human and systemic perspective, not invented by software specialists. This is what Swan Storm means. To design machine, thorough problem identification must be conducted. The problem identification must adopt two approaches. First, systemic approach, and the second one is cognitive approach. After all the problems are identified, only the finding is sent to the specialist of software or hardware system to develop the such system. The focus of identification using systemic approach is to identify problems related to reliability and safety of human-machine interaction. Human-machine interaction can be seen as a process. Reliability and safety can be seen as two complex properties of human-machine interaction and characterized by integrated generalized indicators. Reliability indicator as R, safety indicator as SF. This is basically how problem identification is conducted using systemic approach. Investigation to identify any problems related to the objective of system, its function, and their indicators is designed for systemic approach. Pre-tests need to be conducted. Simulation normally is run to identify any possible problems. After the investigation is complete, the modification or design of processes and systems according to the selected attributes is recorded and will to be improved. In the systemic approach, the physical environment, organization, and psychosocial environment also will be investigated. This is to ensure that all the possible causes of human error is tackled. Previously, I mentioned about how the problem identification is conducted. The problem identification must adopt two approaches. First, systemic approach, and the second one is cognitive approach. So, this is the second approach of problem identification, which is cognitive approach. The cognitive approach is psychology in a relative modern approach to human behavior that focuses on how we think. It assumes that our thought process affects the way in which we behave. Human-computer interaction is the intersection between the social and cognitive sciences on the other hand, and computer science and technology on the other. Human-computer interaction researchers analyze and design interaction technology. Example, displays and pointing devices, gestures, and also sketching. They also study how to improve the processes of technology development, such as usability evaluation, software toolkits, and cognitive ethnography. In 1995, Professor Douglas has presented in first international conference of cognitive technology about to stress the need for a radically new way of thinking about the impact of computer technology on humans, especially on the human mind. His aim at that time was a consideration of this effect with respect to rendering the interface between people and computer more human. This is also can be applied to design any human-machine interaction in the workplace. The broad perspective of cognitive approach can be seen in this diagram. Cognitive approach consists of systemic, psychology, physics mindware applied to the identification of mental processes of humans and living systems. It can be used in the development of universal theory of cognition, applied to a living system, applied to autonomous hardware or software system, and towards the end, it's applied to human-machine interaction. That's all for now. See you in the next slide. Thank you.